I spent $600 on 30 Raspberry Pi 0Ws so I could scrape product stock info off of big websites like Best Buy, Newegg, Sony, and more. I wanted to be the first one to buy GPUs and PS5s. Everybody remembers the scalper bots that would insta-buy big ticket items like the PS5 and GPUs. Well, if you can't beat them, join them. This is how I tried to build a scalper bot. Last year, I got frustrated with all the people telling me that it was impossible to get a PS5. Since they were selling out so fast, no one could get a hold of one. During Christmas, I decided to prove everybody wrong. I followed a Twitter bot account that tweeted out when things were in stock and managed to buy the PS5 in a couple days through PS Direct. I saw all of these scalper bots that made it impossible to get PS5s, GPUs, and whatever else for the average person. I needed to create something to be able to fight back. My first design was fairly simple. I created a node project with a couple of things. I chose Puppeteer to scrape data because I was familiar with JavaScript and the whole web ecosystem. This was coupled with a couple other node libraries like Axios, Cheerio, Bull.js, and CLUI. I decided to go for a more CLI based app than a GUI based one, although the first version was kind of hybrid. I started to create the app with the first tested website being Best Buy. My app would launch the scraper, log in with the provided credentials in the config, and access the page that I needed to. It would then get the element that displayed the in-stock or out-of-stock info for that product, and I returned it as a data point to my app. One flaw that I saw early on was that I needed to constantly send GET requests to these websites if I wanted updated stock info. If something went into stock, it was a matter of milliseconds before all of these bots started buying. I started by refreshing once every second. After a while, the website's built-in scraping protections would block me. This is where I took the next logical step. I tried to see if they had an API. Best Buy did have an API, but the stock information was hidden unless you had a special API key. So I still had to do the scraping. I needed proxies. What is a proxy? A proxy is a device or connection that acts as an intermediary between a client requesting a resource and the server providing that resource. For example, if I wanted to send a server a post message that had the data hello, I could send it directly. If I kept sending that message constantly, depending on their security features, like DDoS protection, eventually that server would block my requests, since they come from the same IP. If I used a proxy, I could send it through a different IP. See how that could come in handy? And not just one proxy, I needed rotating proxies. The type where an endpoint would send your GET request through one computer, then rotate it to another so your request would come from somewhere else. That was the basic premise to get around these website protections. The problem was, rotating proxies cost money. I tried creating my own scraper that scraped free proxies and put them into rotation, but the percentage of those proxies that were healthy were so low that it didn't really work. I decided I was going to create my own rotating proxies. If I had enough of my own proxies, I could design an algorithm that would rotate them constantly enough through the different websites that none of them should get blocked. At least that was my theory. I went to my nearest Microcenter and bought 30 Raspberry Pi 0Ws, 30 16GB micro SD cards, a ton of micro USB power cables, and a ton of USB hubs. The employees looked at me like I was crazy, and maybe I was. Anyways, after purchasing all of my materials, I returned to my apartment. I put all 30 Raspberry Pis on a board made out of some plaster material. I stuck everything on using command strips. I don't have the final picture of this as I sold them all, and I never thought I was going to be making a YouTube video about this. So here's my accurate photoshopped image of what it used to look like. At the time of this project, I was living on campus. We had gigabit internet and one Ethernet port per room. Since this Ethernet port would only supply one MAC address, I realized that I can't hardwire any of the Raspberry Pis, and that's why I chose the wireless ones versus just Raspberry Pi Zeros. The school has a system where you can assign unique IPs to any of your devices on campus if you provided their MAC address. So the school would assign one of their IPs to your device from their allocated IP block range. This way I could have 30 Raspberry Pis, each with their own unique IP to help prevent my scraper from being blocked. My plan was to have all 30 Raspberry Pis function as proxies, have a beefy Raspberry Pi 4 to be the central server, and access that server through a React app it was also running from any other device. I had a queue system for the central server, so the scraper jobs wouldn't interfere with each other. I multi-threaded the queue so I could have multiple scrapers running at the same time, without any interference. How would the scrapers know what to scrape? I needed to decide on some sort of database schema. In the original code, I only had Best Buy, so my data schema looked pretty simple. I had an object, the keys were the name of the items I was scraping for, and the values were the link URLs. After looking at a couple different sites, I realized that there could be more than one link for a single item. For example, the same GPU but by a different company. I updated my database to be more inclusive of that. All I did was change the value from just a link to an array of links. If an item had an array of links, to show that something was in stock or out of stock, all you have to do is check the set containing every link output. In a set, there are no duplicate elements. So if all of the items were in stock, the set would say in stock. If all of them were out of stock, the set would say out of stock. If there were some in stock and some out of stock, the set will now contain two values. If the set contained two values, it would still be considered in stock. That was the logic flow I decided on. The rotating proxy algorithm. Imagine I had three websites: PS Direct, Newegg, and Best Buy. Each website had three unique items to scrape. Let's say a PS5, 3080, and a 3080 Ti. If I have 30 proxies, what would be the most optimal algorithm to rotate them to prevent blockage? The best way I found to do this is to divide them up. One proxy can hit the three items in three separate stores and not get blocked. Basically, for every iteration, every item had one proxy assigned to it, and then that proxy would get rotated the next iteration. Since I had 30 proxies, I could do 10 rotations for 3 websites with 3 items. I realized this wasn't really enough since I wanted to refresh a lot faster, and that was one of the contributing factors to the abandonment of this project. Sadly, I only have the original CLI code I wrote for this bot. I also wrote a revised version in React that had far more functionality but have lost the code since I had to give up my laptop. Ultimately, this project didn't work because proxies were super finicky on the school network. It's hard to do things when you're limited by a firewall and other network rules. I remember a third option I was considering, and that was using AWS Lambda for proxies, since you just had to pay for individual requests. Lambda servers were easy to spin up, and they all individually had a unique IP. After calculating all of the pricing information, I realized that it would still be very expensive for me to implement. So that sucked. I wish I had all the code to show you guys for this project, but I did this years ago, and I'm just glad I'm able to make a YouTube video about it. Make sure to learn from my mistakes and always back everything up on GitHub. It sucks not being able to access code you spent a ton of time working on. I hope you enjoyed the process of me creating this project, as well as my thoughts going through it. Let me know what you think about this project in the comments, and let me know if you've ever done something crazy like this. I'd love to hear your stories. Thank you for watching. Make sure to like and subscribe if you enjoyed the video, and I'll see you in the next one. Peace.